Alright guys, so this video is going to focus on how to multiply radicals together. So we're going to start with taking a monomial times a binomial here. Now before we get into actually multiplying radicals, honestly when it comes to multiplying radicals, I always think about them very similar to maybe multiplying an example like this. When I'm looking at this example over here, x times 2x minus 5. The main thing that we need to remember when it comes to that type of multiplication is that typically we can only multiply numbers together and then we can multiply variables together. Right? So if I'm going to do this kind of multiplication, well, technically I'm just going to drop down the 2 and x times an x is x squared. Minus x times 5, you can't really multiply that together, so that kind of just drops down together. And the same concept applies when it comes to multiplying radicals. If we're multiplying radicals, well, you can multiply a radical with a radical together. Otherwise, a number and a radical kind of just get combined. So the way that that's going to look here, so I have this square root of 3 on the outside of the parentheses. This is the distributive property. Square root of 3 is going to get distributed to everything inside the parentheses. So remembering radical times radical, I can do that. Radical times number just drops down. So when I do square root of 3 times square root of 12, where we're going to use the product rule to actually multiply that together, 3 times 12 is 36, so I'll be left with the square root of 36. Drop down that minus sign, and now we have square root of 3 times 4. Radical is not the same thing as a number, so I'm just going to drop down 4 square roots of 3. 4, just make sure that the numbers go in front of the radicals. They're just simpler, they're just prettier that way. It tends to be proper form. Otherwise, after you're done distributing, just check to see if there is any simplifying that you can do. Can any of the radicals be simplified? Are there any numbers to be combined or anything like that? And when I'm looking at this specific problem here, square root of 36 is actually a perfect square. We can take the square root of 36 because that is a 6. So I'm going to change that into a 6. But then looking over here at 4 square roots of 3, we cannot simplify square root of 3. There's no way for that to break down. So that's actually just going to drop down. And our answer will be 6 minus 4 square roots of 3. So again, we can combine radicals. Radical and numbers just group together.